Me, personally, when I hear web scale, it's a buzzword, nothing more. The problem of performance is you have to understand how the sausage is made, otherwise you're just doing things at random. Jetty started actually when Greg Wilkins decided, well, I would like to write a bug tracker in Java. Roughly at the same time, some other Australian had the exact same idea. Let me write a bug tracker and I will write my own web server to have my own web tracker on top. And one decided to focus on the web server, that gave us Jetty, and one decided to focus on the bug tracking, and that gave us Atlassian.
Really?
Every single time I asked ChatGPT, write some code for me, it was buggy. So, sorry, I don't trust it.
Hey, and welcome to a new episode of The Marco Show. Today with the topic Scaling the Web, lessons from Jetty, Bitronix, Terracotta, and beyond. I also just learned actually Quartz and Cache. We've got an exciting guest with us today. Hi and welcome. And as always, who are you?
Hi, thanks for having me. So my name is Ludovic Orban, and I've been a software engineer for over 25 years now. And I currently work for WebTide, maintaining and developing the Jetty web server. And I'm more or less the person who most focuses on performance in the team.
Mm-hmm. And the funny thing is, you've asked me before, we chatted before we sat down here and you said, hey, why did I think of you, for example, to invite you to be in the podcast? And my answer is simple, because all the projects I've just mentioned that you're working on, like Jetty and have worked on, Bitronix, Terracotta, everything I have used in the past, I find the whole performance topic super, super interesting. And I'm super excited to talk with you about all these topics now and see where we end up with at the very end. Mm-hmm. That being said, to get into it, to warm up the stage a tiny bit for performance, and I thought when I thought of you, I thought Jetty, web servers essentially, which brings us to the topic of web scale, because people always like to say, hey, my application needs to scale and my tiny startup needs to support 1 million of users right now. For someone who's worked on a web server for such a long time, what does web scale actually mean to you?
Me, personally, when I hear web scale, it's a buzzword, nothing more. Mm-hmm. What else can I say about it? So there are reasons why an application needs a certain amount of performance, but when you say web scale, do you mean I need to serve millions or billions of requests per second like Facebook and Google? Or is it just going to be thousands of requests per day? Mm-hmm. Both are web scale services. And they don't have the same requirements, and they don't have software that works the same way, are written the same way, and are not maintained the same way, and not at the same price.
No, from your experience out there, would you say, I mean, Google, Facebook, really, it's just like 1% of the people out there who actually have that huge million scale issues, and the rest is down to thousands per day, essentially?
No, Facebook and Google are not the only ones. There are thousands of companies on the planet that have a really large need for scale, but we're talking thousands of companies out of millions of companies. Mm-hmm. Most other companies just write software, don't think about optimizations, deploy it in the cloud or on a cheap Dell server. You'll be fine.
Mm-hmm. You'll be fine, yeah.
So that's my experience.
Has, however, something changed in the last 20 years where you would say, I don't know, for whatever reason you see there is maybe some IoT services now where you see, I don't know, some projects where, I don't know, tons of thousands of tiny devices send in requests to some huge web server. Did some of the workloads change from your experience over the last couple of years?
Yes, but again, in my experience, the low-level bits changed quite drastically, but the higher level, so when you are writing the application facing the end users, not really. It's still very high level. It's still usable API. It's still Spring web services, that kind of stuff. But the services behind have changed drastically because CPUs stopped being faster per core, but they started adding more and more and more cores. And the way to write those kind of software is immensely different, and it's way more complicated.
How many people do you think out there, like from a programming skill perspective, are actually able to fully do this job and the job you're doing at the moment?
I don't know. Tens of thousands, hundreds of thousands, millions. I honestly don't know. I hope a lot, because that's very much needed.
Are there any other low-level bits you just mentioned that heavily changed?
Yes, because when you think 15 years ago, you still were mostly running on machines with one CPU that had one core that was running everything. And then a second core appeared, or sometimes you had very expensive machines with multiple CPUs, and then multi-core machines appeared and stuff like that. And the cores were just more or less the same performance. So back in 2010, we were writing software that was optimized for a single core. Now we write software that's optimized to go multi-core. And that's not the same kind of optimization at all.
And something I've been, when I'm doing these sessions with Casey, I wonder, Casey's always very much into, hey, we need to kind of max out our very specific CPU and the instruction set on the CPU, and we need to know the hardware is essentially where this is going to run, which I find super difficult because on Java, we're so abstracted away from Java. First of all, most of the Java developers I know, they don't know where the software will run on, what the machine it will run on. They don't even care or want to know what machine it will run on. And then nowadays, everything containerized, being deployed somewhere on some Kubernetes cluster, whatever. I mean, we're so far removed. And I guess it's rather difficult to then actually write really performant low-level code if you're so far away from the actual hardware.
Yeah, but virtualization is a godsend. It allowed us to use our machines more efficiently. It allowed us to deploy more easily. It gave us Amazon Web Services. It gave us Microsoft Azure, and those services are extremely successful for a good reason. But it's true that developing in the cloud is complicated. Well, just don't develop in the cloud. Develop on your local machine. Optimize for your local machine, and the cloud software will make sure that if it works okay on your machine, it should work okay on the cloud, including the performance. So all the performance tricks you apply on your local machine will also apply in the cloud.
Makes sense. Since we've talked a bit about web scale, let's get into Jetty, because that's what you currently work on. And again, I've briefly mentioned it to you before we started here. When I did some research on Jetty and Tomcat, Tomcat is, for whatever reason, the default choice in frameworks like Spring Boot, for example. You can use Jetty with it, but you just need to do some configuration, extra configuration for it. And then I noticed that Jetty seems actually to be older than Tomcat, from the Wikipedia page at least. Or I don't know if it's a years or months or whatever, but around the same page. Could you just give us a bit of background on when Jetty started, how long this has been going on? And then at the end of the day, why you think that nowadays that Tomcat seemingly kind of won the race, at least as default in some certain, other frameworks like Spring Boot?
That's many questions.
Yeah, many
asking.
questions in one. Yeah.
So regarding the history, so Jetty is really old. It's already 30 years old. So the very first version of what we call Jetty actually ran on, I think, the first beta virtual machine. I'm quite a youngster in the team. I've been working for WebTide for only 5 years. I'm not the most familiar person with the history, but from war stories that have been told between us, Jetty started actually when Greg Wilkins, the original author, decided, well, I would like to write a bug tracker in Java. And back in those days, on the 1.0 virtual machine, there wasn't very much. So he had to write his own web server, and on top of his own web server, his own web tracking application. And funny thing, I'm not 100% certain of what I'm going to say. Maybe I will miss some details and things like that. But Greg Wilkins is Australian. And at the same time, roughly at the same time, some other Australian had the exact same idea. Let me write a bug tracker, and I will write my own web server to have my own web tracker on top. And one decided to focus on the web server, that gave us Jetty, and one decided to focus on the bug tracking, and that gave us Atlassian.
Really? That gave us, okay. That is an interesting story to dig down deeper. Interesting. Okay. And then Jetty just continues, then I guess, you don't know much about, you probably can't tell much about the history of Tomcat, but I always wondered, how can it be that you have these two very popular projects around, for so long, essentially?
I can only guess. I think Tomcat is more popular because when the servlet standard was decided, it was chosen as the reference implementation. I think that's why it's more popular.
And do you know why it was chosen?
No idea.
No idea. It's interesting. From your perspective, though, is there anything where you would say, hey, for the outsider's perspective, can you compare Jetty and Tomcat in terms of, scalability, performance, anything like that? Do you actually, as a team, have a look at maybe what Tomcat is doing and what you're doing?
In matter of performance, we heard rumors that Tomcat's performance is adequate and it could be extremely good. We don't know. We don't really test it. We know that it's good enough for most requirements. And we sometimes dig into Tomcat code when there is something really weird in the servlet spec, like, it's unclear, and we do things like that. We wonder what Tomcat is doing. Do they have the same problems? That kind of stuff. When we were chasing bugs and weirdnesses in our implementations.
Right.
Otherwise, we don't really look at it. We know it's a decent piece of software, and they're competitors, and we speak to them. And sometimes when there are CVs that impact the whole web server stuff, like there was maybe 6 months or a year ago, a CV about HTTP 2. So all the web servers on the planet were impacted. So we had to speak a little bit with Tomcat.
Right. And in general, if someone, a hypothetical scenario, but if you try to sell Jetty to someone at a booth at a conference, how do you usually tell people, hey, this is why you should be using Jetty as opposed to Tomcat in this scenario?
Well, it's always the same answer. It depends on their requirements. I would try to collect their requirements and say how Jetty is better fitted for that. But generally speaking, when we try to market Jetty, we use that short sentence that says, what is Jetty? Jetty is a fast web server. We emphasize it's fast. It's meant to be fast.
Then my next question would be, what does fast actually mean to the user?
To the user, back in the old days, it was really visible, and these days it's still appreciated, but less visible. It's the fact that it was capable of starting instantly, less than was 1 second startup time, compared to Tomcat was taking maybe tens of seconds. I don't know, I can't remember. And it's not something that just happened by accident. It was always a requirement. Fast startup and fast runtime. So fast at processing, fast at parsing, and fast at handing the CPU to your servlet code so that your code executes as fast as possible with caches as warm as possible.
When you now work on Jetty, do you then actually try to, continually squeeze, this performance out of Jetty all the time? Or what do you currently actually work on when it comes to Jetty?
There is a constant trend of, is that going to be performant?
Okay.
So every single time we modify a piece of software that could have an impact of performance, we always have that in mind. Is that going to still be performant? And sometimes we reject our own pull request because, no, that's the fast pass and you're going to make it less performant. So no, we won't do that. And from time to time, we run into a period of, let's focus solely on performance. So we make massive measurements like what I taught you. And we decide on some benchmarks and we try to optimize what we have to try to squeeze out even more performance.
And what I might have to tell the audience just real quick is that a couple of years ago, I think it was 3 years ago or whatever, I don't quite remember how we first got in touch, but I wanted to do some talks on load testing, performance and whatnot. And you actually guided me a long way through on how to approach the whole topic. You shared back then the knowledge and also the Jetty performance framework. Is that the right name? I think you have some... load test,
Jetty load testing
framework, which I used and also for the talk. And I have to retrospectively thank you for sharing the knowledge back in the day.
You're welcome.
And all of that.
For your information, everything I taught you, I didn't learn it myself. I've been taught how to do that. Thank you, Aurelia, by the way.
Yeah, so it's a whole circle of knowledge which goes around. So, but then just out of interest, what do you currently work on? Like, if I asked you what are you currently working on this week or this month in Jetty?
In the past few weeks, I've been very busy fixing really nasty bugs in HTTP 2.
Okay.
Because we released Jetty 1.12.1 a couple months ago. It started getting adopted and people reported, we're very sorry, really bad bugs in the HTTP 2. Like there were some packet corruptions or the compression that wasn't working anymore or was leaking. We're sorry about that. So I've been busy fixing nasty bugs.
Okay. And WebTide, the company behind Jetty, do you have to imagine you also do tons of consulting for customers? I mean, do you actually send, maybe even yourself to, these bigger companies who seemingly have some sort of, web scaling issues or whatever it is?
No, we don't do consulting per se. So all the WebTide employees are working on Jetty core on the web server, trying to improve it. But there are so many things in Jetty that there are very many different topics.
Mm-hmm.
So how we make money is by selling support contracts, but the support contracts are depending on how much money you pay, what kind of tier you sign up for. You get quite an exhaustive support. Like if you say, oh, we're having a performance issue, we'll look into it. And even if we figure out, it's not exactly Jetty, but Jetty is in the line, we'll help you through. And we have customers that are coming to us saying, oh, when we do HTTP stuff, it's slow. And yeah, it's not because of the Jetty client or the Jetty server, but we'll help you understanding what's going on, understanding your application, and figure out where the pain points are and help you out.
Does that mean even if I have, let's say a regular, Hibernate Spring application, whatever, and Jetty is in the line, you will actually help them dig deeper into what the...
Absolutely, yes. We have customers that are running the full Spring stack with all bells and whistles you can imagine, and eventually use Jetty in one way and are complaining it is slow. We just don't stop at saying, oh, we've proven it's not Jetty, so now it's your problem.
Mm-hmm.
We try to help them out as much as we can. Of course, we're not Spring experts. We're not experts of many, many things, but at least we tell them, this is how we identified that the problem is not Jetty. And it seems that the problem is in that area. Maybe you could try this or that, or maybe by tuning Jetty this way or that way, it could help things. We try to go as far as we can.
Right. And that means when I want to do my next profiling talk or write my next profiling guide, you're probably also someone to have in mind to ask some questions about.
You'd be welcome to ask.
Right. Then let's move from web servers a tiny bit to transaction managers. Because, and here I need to get a bit of background. You're also the, correct me if I'm wrong, creator of Bitronix, which is a distributed transaction manager. Is that correct?
That's correct.
Right. And then maybe for the new kids on the block, I don't know, but back in the day, 10 years ago or so, we try to, in the company I worked for back in the day, we try to, I guess, have some microservices or whatever that was called back in the day. And we said, hey, we don't want to have eventual consistency, but we actually would like to have database transactions spawning across these different microservices. And then what you need to make it happen, you need a distributed transaction manager, for example.
Yes.
We had a look around, and Bitronix was one of these options. Just in general, because it's such a niche topic, what motivated you to build Bitronix in the first place? How did you come up with that idea? And I think it's a recurring theme, and we'll go through it in the podcast, that you work on Jetty, Bitronix. So why Bitronix? How did that come about?
It's a very simple story. I had a need. There was nothing on the market. So I wrote it myself.
And there was really nothing on the market?
I started working Bitronix like in 2004, something like that. And there was no open source transaction manager that was working back in those days. There was Arjuna and there was Atomikos, but they were closed source and paying. And I didn't have budget for that, the company I was working for.
What gave you the confidence? So I understand, but what gave you the confidence back then to say, hey, we're just going to figure it out. Doesn't matter. I'm just going to write a distributed transaction manager because it's not like writing a simple Hello World application.
I thought it would be fun and I was naive.
And did you know what to do, kind of? I mean, were you learning along the way?
I was naive because I was confident, oh, come on, I've been working in distributed transactions and I've been taught the basics by somebody who was very knowledgeable. So we're talking early 2000s. And I was working with somebody who was quite old, like well over 50 years old, working for a bank on old applications. And he was an IBM WebSphere and all the PL1, COBOL. He was working to that. And he said, oh, we want to rewrite this kind of software here, and you're going to integrate with it, and we need to run into a Kix transaction, and you're going to use the WebSphere transaction manager, and you have the API in Java. Just do that, and it will work. Easy. I know everything I need to know. I can write my own. Because I used it. It wasn't that difficult. And there was somebody very knowledgeable who helped me, and it really did not look that difficult. And boy, I was wrong.
Boy, I was wrong. And then what happened? How long did this Bitronix story go? How long did you work on it?
I worked it in my weekends and my nights for a few years, just as a hobby.
For a few years, weekends and nights as a hobby?
Yes. And I started building a small community of people who were having fun with me. They were using it in their pet projects or things like that and reporting bugs and asking for features. And I enjoyed that time. It was fun. And I think right before I released 1.0 stable, the JBoss transaction manager got open source. So JBoss acquired Arjuna and open sourced it. And a bit later, Atomikos decided to open source their stuff, but I already had working software that was almost production ready, in my opinion, and a small community. So I decided, I don't care, let's go, let's move on. Let's continue working on that because I'm having fun.
And it was really, you had enough fun to basically spend that time. I mean, you could have also, I don't know, have had another hobby, spend some time, I don't know, climbing mountains, but the open source work, did you ever feel burnt out by doing this, or was it...
I never lost sleep to Bitronix. Mm-hmm. So I did that really in my spare time when I felt like it. Something that caught me by surprise is when I said, oh, this is version 1.0 final release, and I think I pushed it to a code house back in the days. I got surprised by, oh my God, the sheer amount of people who started using it and started requesting support. I was overwhelmed. It was a tsunami. Mm-hmm. So one day I had 10 people using it. The next day I had hundreds of people using it overnight.
And how did you work that out? I mean, did you try to give that support?
Yes, I did. And I believe, I would say I failed because I wanted to keep too much control, have too much of a tight grip on the project, and I shouldn't have done that. Mm-hmm. It should have been more open source. Like I got requests for help, so people started sending patches, and somebody like Brett Wooldridge joined because he said, oh, that part is not that great, let me rewrite it. And I wanted to fully understand it before accepting the patch and everything, and
right.
I messed up my own project.
Right. I guess it's, super tricky to get to be able to understand every single line that anyone just sends in.
And it was a one-person project, and I didn't have that much experience in open source. It was my first true experience in open source. I didn't know exactly what to do, so I made mistakes on the way.
Mm-hmm. And is that also why at some point then kind of, I don't know if the word is fizzled out. I mean, now it's not super in active development anymore. It hasn't been in development, or what happened then towards the end?
I think I gave up in early 2010 or 11 because I didn't have enough time anymore and I lost interest.
Okay. Just in general, what do you think where this whole concept of distributed database transactions stands nowadays? I mean, do you think, Was that a useful stepping stone to something? Do you still see it being used today? I mean, what do people do with it nowadays?
It's an immense topic, very deep. So Bitronix is just an implementation of one teeny tiny part. So distributed transactions, there are very many things you could call that way. Bitronix just implements the XA standard via the Java JTA API. And XA is just blocking with two-phase commit and presumed abort and all the bells and whistles that maybe people familiar with that know about. But it's blocking. And it's not meant for the web. It's meant for databases that are behind a firewall that are 100%, as close to 100% reliable. And when they're not reliable, the whole company is down and you wait for the sysadmins to fix them up. If you need transactions over the web, don't use XA. It's going to bite you in the back end, at the rear, at the wrong time. It's not meant for that. What you need if you want things like, I would like to book a hotel and a flight, and if I cannot book both, I would like to book a flight at company A and an hotel at company B, and if I cannot book both, I want to book none. So a form of transaction, but across two companies that don't have the same data center and that are available across the web. For doing that, what you need is compensating transactions that are a totally different beast.
Can you elaborate a bit on compensating transactions? I mean, what they are, how they work, and just conceptually?
It's the same idea of it's a transaction, except that it's not exactly respecting ACID. And it's a bit loose, a bit willy-nilly, how you're doing, how you can. And basically, some of the implementation details, like, the databases are doing things in the background where they're doing transactions about keeping both copies and things like that. That is somewhat exposed in compensating transactions, because you're basically running through a state machine that's guaranteeing your transaction. What is done in the back in a normal database transaction is somewhat exposed in a compensating transaction.
If people want to follow up on this topic and deep dive down into this rabbit hole, where would they go? How could they learn about all of this?
Personal opinion, the best implementation I've seen of a compensating transaction framework with very knowledgeable and very helpful persons is the Atomikos company. Go contact them, go read their documentation, go try their product.
Right. Atomikos, the other
Belgian transaction manager.
Are they also Belgium?
They're also Belgian, and we work together.
What is it with all the Belgians? I've been telling you. I mean, you're the third Belgian person I'm interviewing, and then now okay, I see.
We have 600 beers and 2 transaction managers.
that is quite the ratio, to be honest. Okay, and I might just actually do that by myself and figure out how to approach this topic, because I think many people struggle with it and many companies might struggle with it. And let's see. Right, talking about the past. So we have Bitronix, and the funny thing is, I also learned you have worked on Terracotta.
Yes, I have.
Terracotta, for people who don't know. In simple terms, I guess, you could cluster JVMs.
Correct.
Across multiple machines.
Yes.
Where did that idea come from?
If you had met the Terracotta founders, you would have understood immediately, oh my God, they're that crazy. Of course, they would have such a silly idea.
Well, what was it with them? What made them so crazy?
I don't know. They were a bunch of friends in the Silicon Valley who decided, I'm sure we can do that. Well, let's make a company. Let's find some funding and let's go do it. How hard can it be? But I have to say, they were absurdly talented, because out of an absolutely crazy idea, they managed to make a product that was really working. That's very impressive.
Mm-hmm. How did you join Terracotta? How did you end up there?
Because at one point, Terracotta was transitioning from clustering virtual machines to clustering EH cache. and they wanted EHCache to be XA compliant. So they tried by themselves, and they failed because it was ridiculously complicated for no reason. And they tried to ask questions around. And back in those days, one of the Terracotta guys was living in Brussels, and I was also working in Brussels. We met together, he asked questions, I answered. We had a great time. And he called me some weeks later, would you be interested in a job to do that for us? Implement the XA support for EHCache.
Okay.
That's how I started working for Terracotta.
Right. And you mentioned before to me that the time working on Terracotta was crazy. Why was it crazy?
Because it was a startup built by friends to have fun, and they wanted to share the fun with the employees, and really they succeeded at that. It was amazing, an amazing piece of software. We were doing things that no one else was doing. It was extremely fun. I learned a ton of stuff. They hired the most competent persons I've ever seen, and they had one simple trick for that. Back in 2010, they hired me. They were in San Francisco. They hired me to work remotely from Belgium. And I wasn't the first one. There were people scattered all around the planet working on Terracotta.
Right.
That's how they attracted the best talents.
Right. Thinking back, by the way, is there anything that Terracotta taught you about, I don't know, about Java, the JVM ecosystem, the limits of what you can do, what you can achieve?
Oh, yes. I learned a lot there. One recurrent problem of the Terracotta product, the product that was clustering virtual machines is you were stuck with a very specific version of the 1.6 virtual machine. So revision 17 was working, 18 was not, 19 we added support, 20 was not. Things like that. And the reason why is because we had to modify the Java classes like JavaLang object. We had to rewrite some bits of it, JavaLang string and other classes like that. We had to change the code to add clustering code. But the problem is that was working as long as the code was interpreted, but as soon as the JIT kicked in, the JIT has, like any compiler, things that are called intrinsics. You know what an intrinsic is?
No.
It's a fundamental operation for a compiler. So when it sees, oh, you want to do compare and swap, you want to do AND, you want to call that special method, actually that special method doesn't exist. It's not backed by a code. I know you're doing that, so I'm just going to generate code for it. So there are classes in JavaLang object and JavaLang string that if you look at the Java code, you see code, but when the compiler kicks in, it doesn't look at the bytecode, try to figure out what it does. It just says, oh, that's an intrinsic method. I'm going to replace it with that bit of code.
Right.
And of course, all our clustering stuff was thrown away.
Right.
So we had to always fiddle around. If we go that route, if we call that, it was always a maze like that to support new versions of the virtual machine.
And were you actually in touch with people who, I don't know, built the JIT compilers back in there? Did you try to play catch up?
Nope,
From
it was all done by reverse engineering.
All done by reverse engineering?
Yes.
All right. So you were kind of aware, hey, a new tiny minor version came out, and then it was back to reverse engineering time of what had changed, or if the entire thing is going to crash.
Well, usually it was, let's try it with the test suite. If it passes, hopefully it's okay. If it breaks, let's figure out what's going wrong. It was as simple as that.
As simple as that, I like it. Yeah?
As simple as that.
Yeah. What happened then to Terracotta, by the way? Because, then at some point, I've told you before, we tried to use it in the first ever company I worked with in a full-time job. We went the Terracotta way. And then again, a couple of years later, it kind of seemed to fizzle out. What happened?
The product was insanely complicated and relied on things that were wrong. Like to cluster a virtual machine, that means you're creating another kind of machine that is, another kind of CPU that is working across machines. That's really what Terracotta was about. It was creating some form of CPU or Java virtual machine that was working across machines. So you had a shared heap, and you had a thread working on a machine was completely identical to a thread running on another machine. So when it was modifying a variable in one virtual machine, those changes had to be made visible to all the other virtual machines in the cluster. So you had to properly understand the Java memory model to understand visibility and locking and things like that. And also other software that you were using, not the one that you were writing, well, that the user or end user or customers of Terracotta were using, but things like Hibernate or Log4j or any library you can think of that were writing also multi-threaded code and had concurrency bugs were just plain broken on Terracotta. Mm-hmm. And when a race condition appeared, most of the time that crashed the entire cluster. So Terracotta's workaround was for the most used libraries. Some of them, like Hibernate, they accepted patches. Some others, I can't remember which ones, I couldn't name them all. They did not accept patches, or it was too hard or whatever. So we patched them live. When we had the class loader of the virtual machine, we were detecting, oh, it's this class. We're going to patch the bytecode to fix the race condition.
No way.
Terracotta was doing that.
How is that even? I mean, doesn't it take an insane amount of, sorry for a better word, naivety to tackle this entire complex thing, because it sounds impossible. It sounds impossible from every angle, so to speak, from reverse engineering the latest changes to hot patching, third-party code. It sounds insane.
It was, but that gave us two benefits. It was a lot of fun, and when it worked, boy, it was amazing. To have a clustered virtual machine that you could deploy across dozens of machines, and just by snapping your fingers, boom, your application was running on 12 different machines by doing nothing special. That was absolutely amazing. It was fully transparent clustering.
Mm-hmm. Who funded the project, by the way? Who funded Terracotta initially?
I don't know.
I would just be interested in who initially gave the money to got that the team working on all of this.
We should dig the web, look into history, but I think from the top of my head, I would say it's classic VCs of the Silicon Valley.
Classic VCs.
So you'll probably find common names of the days. I had the time of my life there.
The time of my life.
It was a once-in-a-lifetime experience. I enjoyed every single minute I spent there.
For how long did you work there?
I worked for Terracotta for 2.5 years before it was acquired by Software AG, and I moved on working for Software AG, and in total I worked for 10 years on Terracotta products.
Okay, on Terracotta products. Interesting. All right. Which means, talking about Terracotta, clustering and whatever, and actually all your expertise from the entire topic, I wanted to talk a bit about high performance and scalability in the Java world, and just best practices and Java performance in general. And maybe this is just essentially what we talked about when you taught me a bit about the performance testing a couple of years ago. But just in general, what would you, just to start off, what do you see the most common performance mistakes that Java developers or developers in general would actually do or would actually make? And maybe it's not so much even about a specific, error in a specific, hot loop, whatever, but also about mindset in general. When it comes to performance.
Well, the problem of performance is you have to understand how the sausage is made. Otherwise, you're just doing things at random. Mm-hmm. CPUs have evolved drastically in the past 30 years or so. They are not working the same internally at all, meaning that the things you need to do to get performance software is wildly different nowadays than it was from the 90s. So if you write performance software for the 90s, it's not performant software in the 2020s. Mm-hmm. So you have to understand how CPUs are working so you can write performant code. And that's, I think, the most common mistakes. People assume things. I've been taught at school back in the days that I should write code that way. And things have evolved. It's not true anymore. So as a summary, the first thing you have to keep in mind is these days, memory is the new disk, and the CPU truly acting on data is just blips between waiting for the memory to come back.
Mm-hmm.
That's what happens most of the time. The CPU just executes a few hundred instructions and waits long enough to execute thousands of instructions, just waiting for the memory to come back with a read request.
Mm-hmm.
So you have to do the most with your caches, and you have to collocate the data as much as you can. Things like that.
When I'm now doing these episodes with Casey on the Java 1 Billion Row Challenge, then Casey told me at the beginning that he would like it to, do it the other way around that I've seen it done in most companies. Most companies, you write your software, you never care about performance, as the topmost priority, essentially. And then at some point, the software blows up, and to make it very visual, you try to register a user on a website, and then take seconds or whatever, because for example, tons of SQL queries are being generated across multiple systems and whatever. Then the profiling starts, and then you try to randomly kind of do stuff, or you try to find out, hey, what could be the bottleneck? And then you're happy if you can reduce the time a tiny bit, to what it was before. But then Casey came in and said, hey, let's do the other way around. Let's start from a bottom-up performance approach. What should the very, very lowest baseline actually be without all the other stuff around it? And then work our way up, so to speak. So instead of top to bottom, bottom to up. And I think, to be honest, for performance reasons, it is the right approach, but actually it's not something that I see people do in real life, because for many reasons, because they don't know how the sausage is made and they couldn't actually approach it from the very bottom, so to speak, or they don't have time, or they don't have whatever. What do you think about that?
Well, I'm not certain what motivates Casey from working from bottom up. Is it because he's used to work that way, because in his day job, that's the way things work? Or if it's just illustration because I want to teach you how the sausage is made? Don't know about that, but you do need to understand how the sausage is made. So at least for the learning process, I think it's a good idea to start from the bottom. But otherwise, if I or anybody else I have a performance issue on my application, where do I start? Well, learning how to measure a performance issue is a skill that's not as common as it should be. And you should start learning profilers and the different kinds of profilers, the different kind of profiling they can do, how to use them, what are their weaknesses, their strong points, how to read their measurements, what you think you can assume that you're wrong. It's a new world of things that you have to learn. How to measure an application to see if it's performant or not. And as you experience firsthand, it sounds easy and it's not.
It's not. And also I find, and I think we wrote about it in the emails, again, it's hard to find some guidance, really. Probably if I went to Brussels again and then I met some people there in Brussels who work on this performance code, it might be different. But again, how as a poor soul, Java soul, what do I do? How do I get into this topic? I could actually, I talked with you. I thought, hey, you had the knowledge, but how would I approach this? How would I learn about it?
That's a question I've been asking myself for well over a decade, and I have no real answer. There are people like Casey who are knowledgeable and are trying to share the knowledge and are good at sharing the knowledge. Great. But it's just one small piece of the puzzle. And I honestly don't know. I've been lucky enough to learn from people who knew. Mm-hmm. So I've just been standing on the shoulder of giants, and giants are not that common in the wild. Mm-hmm. So I'm very sorry, but I have no good answer to give you.
Have you ever tried publicly sharing a lot? I don't know, creating, I don't want to say courses, but material or anything to the wild?
Yes, I have. Back in the Terracotta days, everybody was trying to submit things about performance topics. But unfortunately, it's not very sexy. Well, that's my opinion. It's not very sexy, so we weren't very often accepted to conferences.
So you actually submitted talks and they said, whatever.
Some people were more successful because they were good talkers, but most people, at least me, I was very often rejected because it doesn't sound too interesting. But I gave a few talks here and there. if you dig deep enough on the web, you will find me giving presentations decades ago.
Honestly, I wonder how one can make this entire topic approachable, because I think it's an important topic. I think it's a very cool topic also. I wonder what it takes to make it approachable to the masses, kind of. Yeah.
If you find an answer to that question, please tell me. In the meantime, if you have questions, I'll happily answer them all.
Right. Which means also we need to, I guess, give people, I don't know, write the comments down below under this video, and then we'll forward them to Ludovic. Yeah, we'll make sure it happens.
And I'll do my best to answer them all.
Yep. You already touched a bit about it early on. And it has to do with the sausages being made. From my experience, again, developers nowadays, you have your Java application, then came the containerization. And from my perspective, a lot of developers also don't necessarily, I mean, they don't want to know how the sausage is made. And then when it comes to scaling, they think, well, we just have it in a container now. And for whatever reason, the Kubernetes cluster itself will then automatically kind of scale it to whatever kind of the needs are of that application. Do you think that developers rely way too much on just hoping the whole Kubernetes, whatever, will fix it for them? And are they aware of how does that even work out, that they can just deploy it and then it just works and runs?
In my opinion, no, they're not over-reliant. It's good that they're relying to, I'm writing software and Kubernetes, Amazon Web Services and whatnot are promising me that it's going to be performant, and it is performant. Awesome. No need to worry about it. The sad part is, when it's not performant, what do? I have no clue. Otherwise, no, I don't think that people are too reliant on that. I would say it's normal. That is the job of the people working on Kubernetes, on web servers, on application servers, to adapt to all that and take all the complexity and abstract it out. It's a great model, and it worked for decades, and it's still working fine. So most people, you deploy to Kubernetes, and it's super fast, and you can web scale without thinking about it. It works out of the box. I'm very happy that we live in such a world. But there are people behind the curtains that are aware of what it takes to make that fast.
Right. And I guess when then the problems, as you mentioned, happen, then suddenly you have like a couple of more abstraction layers in between, and you need to, I mean, the sausage gets more and more and more and more complex along the way.
Yeah. And even I don't understand all the layers of all the bits and how to make the sausage. And even on things that I'm supposedly an expert, I don't know everything, and all my knowledge is approximate. I know more or less how to write performant code, what makes code performant or not. And I have a mental model that I follow, and that's good enough 80% of the time. Mm-hmm. And when it's not good enough, I know where to look. That's it. So sometimes I say things that are not completely right or almost wrong, but they're more or less good enough to guide you in the right direction. Mm-hmm. Mm-hmm. Because it's way too complex. There are way too many things and too little time, and also too little information available. It's really hard to find good information about how all that works.
Mm-hmm. Is there anything in general, by the way, in terms of software, which excites you at the moment? I mean, any trend, anything? It could be some software architecture. It could be something happening, I mean, in the AI world. It could be on the performance topic. Anything that excites you, where you think, hey, this is a hot topic?
Hot topic, I don't know. Usually I don't really like things that are trendy, like AI or before that, IoT. I find that personally boring. Mm-hmm. But one thing that really impressed me when it went out, it's new hardware made by Oxide Computer.
Okay.
That thing is absolutely amazing.
What is that?
Oxide Computer, they have built a rack computer. So it's a computer that's the size of a rack. It fits in the rack. And they've redesigned the computer from scratch. The electronics, how it's powered, meaning they develop their own power supplies. They share the electricity in the rack in a totally new way. They buy CPUs from AMD, but they rewrote the firmware. So the AMD Ageza or things like that control all the little cores that control the memory controller or the PCI Express stuff. They rewrote all that with the help of AMD so that their operating system, that is their own, understand all the things without any abstraction. They have a total control of every single bit of the hardware.
Okay.
And that allows them to report way more details than any other thing on the planet, just because they have total control of everything. And I find it extremely interesting because eventually, in the end, it is seen as a Kubernetes server, something like that, where you just deploy virtual machines.
Right. Interesting. I need to check that out later on.
It's absolutely amazing because they were developing that during the COVID pandemic. So I had a ton of time to follow their work. And they had a ton of time to make videos, to share what they were doing.
Mm-hmm. Okay, thanks for mentioning.
You're welcome.
Now I need to bring down your excitement probably a tiny bit more because what is your take on AI? I mean, just your short say. Do you kind of use AI when you develop? I mean, or when you not develop? What's your take?
I do. Yes, I ask ChatGPT or other AIs questions about. If I do this, is that going to work? Or does Hotspot do that? Like a question I asked recently to ChatGPT is, can the C2 compiler generate codes that call into the interpreter? And it told me, oh, yes, because if you look at this bit of the code, you will see that it will generate assembly that looks like that, and it's just a trap to call into the interpreter. Thank you very much. And I don't have to read 1,000 lines of code.
And do you trust it, though? Do you trust that? I mean, these statements, though, because I found sometimes I got in such problems where I got these confident answers, obviously, and then they were just wrong in a tiny detail, a very important tiny detail. And then I started questioning now. Now I'm always in questioning mode and I have to reread the documentation behind it often.
I don't trust code written by AI because every single time I looked at the code, so it's either something I don't understand at all, like, oh, write me Python that does this, or write me some CSS that does that. I have no idea if it's correct or not, so I'll just blindly trust it. But if I ask it, write me some Java code that's going to go into a folder containing files and go into every subfolder, or just list the files, it's generating code, I read it, it's buggy. Mm-hmm. Every single time I ask ChatGPT, write some code for me, it was buggy. Mm-hmm. So sorry, I don't trust it.
Yep.
But it's a good help nevertheless.
Yeah. I think if you know what you're doing, it's a good help nevertheless. I think it could be difficult for people getting into the field, kind of over-relying on it. And then you cannot, judge the output. Then I think it's potentially dangerous.
I think you said it right. Don't over-rely on it. Yeah. It's just a tool after all.
Yeah. Yeah.
And remember the saying that says, when all you have is a hammer, everything looks like a nail. Yeah. Don't be that person.
Yep.
Have a full toolbox.
Yep. Looking back at your career so far, I mean, we've had Jetty, we've had Bitronix, we've had Terracotta. We haven't talked about Quartz, the scheduler, and Cache. But which of these projects taught you the most about, I guess, writing software, and what just combined in just as a summary in a sentence? What did each of these individual projects kind of teach you?
Bitronix taught me how open source works and how fun it is to work in the open source field. So not too much technical stuff. Well, yeah, it taught me how to write a project from scratch by myself, implementing a JSR. First time ever I implemented a JSR. What Terracotta and Cache taught me, it's pretty much everything I am as a software engineer today. Everything I am now, it's thanks to Terracotta. Jetty, it's a bunch of lovely people working on amazing software. What else can I add?
Mm-hmm. And Quartz, how did Quartz end up there?
Quartz was acquired by Terracotta.
Ah, right.
They acquired both Quartz and Cache because they wanted to move away from clustering virtual machines to just clustering successful software.
Right.
Because it was much easier to patch it in code instead of patching the bytecode and saying we we just want you to use EHCache and Quartz.
Right. For anyone who would try to kind of, it sounds weird, but let's say follow your footsteps and do that sort of technical work, looking back, did it all just happen randomly at the end of the day? I mean, as you said, you met someone in Brussels and then it just happened. I mean, is there any advice you would give people in their career? Or is it all just, a happy random coincidences looking back now?
You could call that happy coincidences, but my advice would be, do not hesitate getting in touch with people who think are knowledgeable. Be gentle, be nice, don't pester them, but get in touch. Usually people, they quite enjoy being contacted and responding, answering questions on their field. I think that was one of the big reasons why it worked well for me, is because I'm just going to send an email to that guy and see if he answers and what he answers.
Mm-hmm. And as you said, you'd be surprised to know how many people, if you're just gentle, they will reply to you. And
yeah, they're happy to reply.
And a nice connection happened. And now we sit here together a couple of years later since we first emailed each other. At the end of these interviews, I always like to do some rapid fire questions. I've told you already that usually what we do is we combine the person's country with some tech topics that we talked about. Given that you're the third Belgian person we've interviewed, there's not going to be beer and chocolate questions anymore. I try to come up with something else. So first question, why do I need to die if I don't use the ZFS file system?
Because that means you don't trust, you don't care too much about your data. So if you die because you lost your data, I'm sorry for you, but you deserve it.
You deserve it, okay. So you've been running on ZFS all day long, all years long?
Okay. I find myself a bit of a brainchild of Sun Microsystems. I really admire that company. And not only for Java, but also for Solaris.
Right.
And when they made ZFS and they explained, we were doing it, it was the very beginning of blogs and the open source Solaris, and they explained really how things were working in an operating system in my opinion, way easier to understand than Linux. Mm-hmm. So I was so happy to learn about that. And again, I contacted Sun employees about, I have a problem on my Solaris server. Oh, you just need to do this, or the library works that way, or try that command. They were super helpful. Mm-hmm. And this ZFS was absolutely amazing because, all those problems, it's because file system problems. It's because of hardware problems that the file system ignores. Mm-hmm. Like a lot of people, I take photos and I store them on a NAS I have at home. And if you look at photos of 15 years ago, sometimes the JPEG is corrupted.
Yep.
And you just have the top of the picture that's rendered and the rest is corrupted.
Yep.
It's because of bit rot. Mm-hmm. I had that 1,000 times on pictures, on music and things like that. Never understood what happened. Mm-hmm. It's just because the hard disks are not reliable. Mm-hmm. And ZFS was designed in a way that if there is such a problem, we can detect it 100% of the time and we can fix it 100% of the time.
What about BTRFS? Same league or different? Or
Same league, yes. Less mature.
Okay. So this wasn't quite a rapid fire answer, but I mean, obviously, it's a great explanation. What's your favorite JVM flag? So when you start up, I don't know, -XX, anything that comes to mind?
XMX.
XMX, I like it.
Usually it solves all your problems.
Right. I kid you not. This is this is what I've seen in real life. Yes, it solves most problems. Any specific person who's your personal performance role model?
Alex Snaps, by far.
Alex Snaps. Okay. And is there one piece of technology or software you wish never existed?
Microsoft Windows.
Microsoft Windows. That came fast. All right. And last but not least, do you want to share the most obscure bugs you've ever spent, I don't know, days tracking down? Is there anything that comes to mind that was so silly, some sort of a bug which comes to mind?
There was a bug that we really enjoyed tracking down and fixing. It was a memory leak caused by some class loader. It was some obscure library that was used by Tomcat, and I fixed it on my way to the airport in San Francisco.
On your way to the airport?
Yes. So I was waiting for my taxi. I was in the office hacking around because it was a bad bug that a customer was complaining about, a big customer. And it was in an area I was responsible for. And I got to understand what it was. Then the taxi came. I was typing with my laptop on my laps on the taxi. Then waiting for my plane. I continued on and I committed the flight. I committed the fix right before I got called to embark.
That is so great.
And it was a really obscure memory leak that was not happening with certain garbage collectors because they were running often enough. But some other garbage collectors were pushing the old gen collection so far in the past that we needed 3 or 4 collections before the thing happened. It was really messy.
That is quite the commitment on the way to the airport, on the way to the flight. Tell you what, Ludovic, thank you very much for sharing these stories. I enjoyed it very much. I think I have a ton more follow-up questions which don't fit into this format anymore. But again, if you want to learn more about performance, about anything we've talked about, leave a comment down below under the video. Ludovic is happy to help. I'm happy to also forward if I can. And just thank you for being here.
Thank you for having me. I had great fun.
All right, I almost forgot. We have a giveaway, a license giveaway, which means you need to answer a question. Write your answer in the comments down below the video. The question is, what do you think? How many bugs Ludovic fixed in the Jetty source code last month, which is, let's say, in the months of October, September, both of them combined together. Whoever comes closest to the real number gets the license. Let us know down in the comments, and I would also like to know how many of these bugs you fixed. Right, enjoy.